All right, this next activity is called composition of functions, where you take two separate functions and you perform an operation and it creates an entirely new function. All right, so first let's look at addition and subtraction operations. This just says you're going to add the f of t plus the g of t. Another way that you might see it is f of t plus g of t, and I'm okay with either notation. So you're just going to take this first function, negative 4t subtract 5, and if you want, put it in parentheses, and you're going to add the second function, negative 3t cubed subtract 2. And then function notation is very, very important. You will lose points on any type of assessment. So you rewrite the notation that's given. And then remember, with polynomials, we want the highest degree to come first. So I'm just kind of going to glance over here. Oh, I notice we have a cubed item, and there are no other cubed items, so I'm going to go ahead and put negative 3t cubed. There are no squared items, so the next one is negative 4t, so negative 4t. And then we have two numbers by themselves. We have negative 5 plus negative 2, and that is negative 7. And for your homework this week, what I'm probably going to have you do is you're going to take each one of these functions, all three of these functions, and you're going to type them into Desmos. So not too difficult, but I want you to see what happens when functions are composed. So down here, we're just going to subtract. We're going to take 3x plus 2. We're going to subtract that second function. And then, again, very important, we're going to rewrite function notation. 3x subtract. Do not forget the subtract. That's very, very key. 3x subtract a negative. Well, that's like adding a positive, so we have 5x. If it helps, you could rewrite it like this. And then we have 2 subtract positive 2. So we have a positive 2 subtract a positive 2. Well, that just zeroes out. So that's your final answer. So in Desmos, what you would do is you would type in this function, hit enter. You'd type in this function, hit enter. And you'd type in this function. And then it would be interesting for you to see kind of what's happening with those functions. All right, we're going to move over here to multiplication. I'm going to give myself a little bit more room. Let me see if that. There we go. All right, now you're going to multiply these two functions. So in parentheses, negative 2x subtract 5 times x squared subtract 2x. You all have been multiplying binomials for a very long time. You can use the FOIL method. I like thinking about it as the double distributive because that works with all polynomial multiplication. So negative 2x. Let me change the color here. We're going to multiply negative 2x times each of those. So negative 2x times x squared is negative 2x. What do you do when you multiply powers of the same base? Add the exponents. So x to the first plus x squared is x cubed. Then we have negative 2x times negative 2x. You get positive 4x squared. All right. Change my colors. Now we're going to take this negative 5 and we're going to multiply it by those two things. So negative 5 times x squared is just negative 5x squared. Negative 5 times negative 2x is positive 10x. And, oh, let's see, did I end up, I want to make sure I didn't end up messing up. Nope, that's an x squared. So we have one more step to do. So g times f of x is equal to negative 2x cubed. These two are alike. They're both x squared. 4 subtract 5, so we have negative x squared plus 10x, and that will be your final answer. For the division one, sometimes they end up being fairly simple. Again, pay attention to which one's on top. So g is this function, 2a subtract 2, and h is a cubed subtract 5a squared. Now, so in this top one, you could factor out a 2, but if you look down below, a 2 is not shared down below. So the one reason to factor is so things can cancel. So we're not going to have to worry about that. And then look at, these both share an a squared, but these two terms up here don't share an a squared. In fact, they both don't share an a. So this one, I would just leave in that final format just like that, because even if you factor things out, they won't cancel. So it doesn't do much to help. All right, and then this final one, you just have to pay attention to what's happening. We're just subtracting like we did on the second one. But this is saying, hey, before you subtract, you have to multiply the f function by 3. So we're going to do 3 times that 4n plus 2. Then we're going to subtract the g function. So then you rewrite it, do the distributive. So 3 times 4n is 12n, 3 times 2 is 6. We're going to subtract n cubed, subtract the negatives like adding a positive, 4n squared, and then we're going to rewrite it in standard form. So we have a negative n cubed, we have a positive 4n squared, we have a positive 12n, and a positive 6. And that's it. That's all there is to let's see, on these type. Oh, there's one more that I need to take care of right here. And it is composing a function inside a function. And I'm going to even give myself a little bit more space. Sorry that I did not see that one. I was all happy that we were done with the video. All right, so when you compose a function inside a function, that means this whole function right here gets composed right inside there. All right, so g of h of n. So I'm going to take this g function, 2, and where there's an n, I'm going to put parentheses. Notice, this is the g function. 2n subtract 5, and where the n was, we're going to insert the h function, which is n plus 1. G of h of n, and we're going to do the distributive. 2 times n is 2n, 2 times 1 is 2, and then we're going to bring down that subtract 5. And the last thing we're going to do is simplify. So 2n minus 3. That's it. That's all there is. These get a little bit harder, but for the easy ones, it's pretty easy. All right, that's it.